Welcome back. I am three people. So we have log equations for you to do today. Hopefully, as long as you've been doing your properties, these log equations will not be too terribly difficult, but you do have to think all the way back to when you used to do quadratic solving and kind of a little bit think back to what a log actually is. We're going to review those things anyways. And you'll see them. But if I skip steps that you kind of think that you needed, listen carefully to what I say and try writing down those steps on a separate piece of paper as you take notes down. Hopefully you're taking notes down about these log equations. So first things first, what is it? A log equation is just an equation whose variables are in the log itself. So these are two examples of log equations because there's an x right here inside of the log. And here's another one. There's an x squared on this side, and there's an x on this side. Now this should kind of be a little bit of a, uh-oh for you guys, is that you do have to deal with x squareds. That means we're probably going to have to think about quadratics. We're probably going to have to do some quadratic factoring here and there. And you might get more than one answer on occasion, so be prepared for that. Now, this is kind of a big deal right here. We've talked about it in our Zoom sessions. I'm not sure if I did too much as far as the actual lessons about this, but I'm telling you now, in a log expression that's a log base b of your argument, there is really one thing you need to know that comes from trying to do these logs. Every log has a value. Every log is just an exponent. And remember that every log is the value of the exponent that if you did that exponent to b, will give you the a, the argument in this case. So what are some things you can't do? If you try and do log base 10, a common log, if you try and do log of 0 in your calculator is going to come back and say, and it's going to say it basically can't do it. If you try plugging in any negative number, any number less than 0, it's going to do the same thing. So the big restriction that we have to worry about is that all of our arguments must be positive. You need to star this, highlight it, underline it, bold it, whatever it is that you need to do to remember that you have to have positive arguments, okay? Now, whenever there's a restriction, we've done some of these before, you might get answers that you can't use. So we're gonna have to talk about that, and that's kind of where these extraneous values, they're called, like values that work for the math that we did but don't work for the actual equation they came from. We're going to have to deal with that. So how do we solve these things? Well, the big goal here is to get each side down to one log. Sometimes you won't have a log on each side. You're only going to have it on one side. That's okay. But wherever you see an equal sign, if there's a log there, you need to get them down to one single log. So here's our steps. Our steps are this. You need to condense, as in write them down or simplify, all log expressions on each side. And the two big properties that you guys have to be familiar with are the fact that when there is addition, so when there's addition, you condense your logs with multiplication. Okay? That is huge. If you guys do not know that rule, all of this is going to be very difficult for you. Likewise, if there is subtraction, what does that mean? That means we condense with division of those two logs, whatever those logs are that are subtracting each other. And those are kind of the big parts that we need to make sure that we're worried about today, is that you can recognize when you have addition and how to put that back into a single log, and when you have subtraction and how to put that back into a single log. Now the thing is, these are hard to do in that you kind of get two different types of questions. So once you have condensed all log expressions on the left and then condensed all log expressions on the right, you're going to want to look at what's left, because it's one of these two things. It's either 2 logs per side, you've already condensed everything down. So there's 2 logs per side, or there's 1 log and it equals a number on the other side. So this is essentially where you kind of have to look at one of these 2 cases is going to happen and how do I deal with them. Okay, so if it's 2 logs on one side, so if it's this case over here where it literally says log something equals log something, all you're going to do is drop the logs, bases included, and solve for what's left. This should feel a lot like when we did exponential equation solving, where sometimes we essentially got everything to be equal to both sides. We drop the bases and we solve. You get to do that for log questions as well. Now, you're going to have some normal solving where you just have to get x by itself, but you're also going to have some quadratic equation solving, as in x factor equations, and you're going to have to actually solve those and remember all of your tricks to doing quadratic solving. Okay, so those are your steps if you have a log per side, a log on each side. If you only have 1 log on one side and it equals a number, or maybe there's 1 log and there's some stuff around it and it's all equal to a number, isolate your log. So get it to say log something equals. And then you're going to rewrite this log in exponential form. So you're going to get something that looks like this. You might do some division, you might do some subtraction, some addition to get to here, but you got to get to this form. Once you do that, you're literally going to rewrite everything and do, all right, the base of my log taken to my power will equal my argument. Okay? Once you do that, you solve essentially for what's left. Those are essentially the 2 ways that you guys are going to have to tackle these types of equations. And extremely important, both of these steps will bring you back to this. You must check your answers by plugging into the original log's arguments and making sure that all arguments are positive. I cannot stress how important this is. You will get what's called extraneous solutions that you can't use. These are kind of like excluded values when you guys did rational equations. This can happen, and in fact, it happens a lot. So I'll show you kind of how to deal with this, but basically, briefly, plug your x numbers back in to all of your original arguments. So that'd be like, plug it into here. Don't worry about anything else. Just worry about this becomes. Plug it in here. Don't worry about anything else. Worry about what it becomes. And just make sure everything's a positive number. And that does not include 0. 0 is not positive. 0 is not negative. So don't think that 0 is positive because it doesn't have a negative sign. That's what you're going to have to check. Now, anything that is not positive, you can't use. As long as you get a positive argument, you'll be in good shape. You can actually solve those. So I have 4 examples for you guys today. Essentially, 2 that had you doing this and 2 that had you guys doing this. Now, these are not going to be obvious the way that you guys get these questions. So just make sure that you're aware of that. Okay? Okay, there we go. Let me lock my wheels. All right. Now, here's our 4 examples that we're going to do. I stopped writing examples. If you guys don't know that I'm doing examples by now, then I kind of feel bad for you. Make sure you have these written down. So here's what's going to happen. First thing we're doing, we're going to condense any and all logs that we have. So on each side. So we're not going to move one log over to the other. We're just going to look on this side. I'm literally going to think of it as left side, right side, and look here. Are there any logs that I can condense over here? There's not another log base 2, so there's nothing for me to do on the left. Over here, there's not another log base 2 on the right, so there's nothing for me to do on the right. Okay? Now I'm going to look at what's left, which is either it's a log per side or it's a log expression that I'm going to have to change later. There's a single log. There is a log on both sides here. This is a very easy, quick example. We are just going to drop the logs and their bases, write down what's left, and start solving. Now, looking at this type of question, I see p squared and I see p. I'm probably going to have to do a quadratic solving type of move here. Since I know that my p squared has to be positive, I'm probably not going to give you guys stuff that doesn't factor. If I did, then I'm in trouble here. I need this p squared to be positive. I'm going to move these guys over here, add 13p to both sides, subtract 1 to both sides. I need this thing to be equal to 0 if I'm going to use quadratics to solve them. Putting all my like terms together here. I'm trying to get p squared plus 13p plus 30. So this is definitely a quadratic. I'm going to set up my x factor and solve. What are two numbers? They're going to times to 30, add or subtract to 13. 10 and 3 will. That ought to do it. So my answers should be, these are my factors. My answers are their opposites, negative 10 and negative 3. All right? Now here's the thing. I have to check to make sure I can use both of these answers by looking at what each of these numbers do to each of these arguments. Well, anytime I square something and add 31, I'm going to get just a bigger positive number. So negative 10, the whole thing squared is 100 plus 31. That's a positive number. This one's okay. If I do the same thing with 3, it's okay over here. But it has to work everywhere. Checking this one out, negative 13. If I did negative 13, plugged in negative 10, and then added 1, I'd get a negative times a positive, which is going to be a positive 130 plus 1. This will be a positive. This negative 10 works on both sides. By the same logic, negative 13 times a 3, that would give me positive 39 plus 1, that gives me 40. All of my answers that I got will work in number 1. Now I know that I went through those kind of fast. I'm just trying to keep these videos low. Please, please, please come see me on Zoom. Tuesdays and Thursdays. If you need to meet with me a different time, that's fine. Just let me know. Okay? All right, moving on to number 2, which is this one down here. This one, I actually might have some stuff to work on. So this is my left side and right side. My equal sign is the great divide. I'm looking to condense if I have multiple logs on one side. Well, looking on the right, it's just log base 9 of 24. There's nothing for me to do there. So all I'm going to do now is look at the left side. Is there any way I can condense this left side? Well, there's a log expression here, a log expression here, and there's addition between my two logs. So what do I have to do? I have to put those two logs together by timesing their arguments together. So if I were to do that, I should get log base 9 of x times x, which is x squared, and x times positive 2, which is 2x. Okay? I know I did that kind of fast, but you guys have got to be able to figure out some of those small missing steps on your own. I'm happy to answer questions on Zoom, so please make sure that you ask. Now, which case do I have here? Is this a log equaling another log, or a single log that I have to isolate? Well, I can look at it right here. Log equals log. So my next step is to drop the bases. I'll have x squared plus 2x equals 24. Seeing that I have x squared and an x tells me I'm probably going to have to use quadratics to solve this. So that means I need this all equal to 0. If I don't have it equal to 0, I can't solve it. Here it is equal to 0. I need to find two numbers that will multiply to negative 24 and add or subtract to a 2. Once I make that happen, then I just change their sign and those are going to be my answers. So what's going to let me do that? Well, let's see. What are two numbers? 12 times 2 will give me 24, but won't add or subtract to a 2. Let's see. 6 and 8, 4 and 6. 4 and 6 will work. 4 and 6 times together will add or subtract to a 2. I need them to times to negative 24, and I need that 2 to be positive. So my numbers are negative 4 and positive 6. So what will actually solve this equation? A positive 4, the opposite of negative 4 will, and negative 6. Okay? Now my next step is to make sure that anywhere I have an x, Plug in 4, make sure all my arguments are positive. Plug in 6, make sure all those, negative 6, make sure all my arguments are positive. So let's take a look. If I plug 4 into here, this would just become a 4. That's positive, that's okay. If I plug 4 in over here, which is also an x, 4 plus 2 is 6, that's positive, that's okay. There's no x's over here, so I can definitely use an answer of 4, all right? Now my next number to check is negative 6. Any number that makes my arguments negative is a number I can't use. So as soon as I take negative 6, plug it into this x, and try and actually solve this thing, or and try and see what the value is, the x will become negative 6. I can't have a negative in my argument. So this negative, I don't even have to check the other one once I see that happening. That is an answer I cannot use. So the only actual answer I can use is x equals positive 4. And all of that came from condensing this log, dropping the logs, factoring a quadratic, and checking my answers. Okay, if you guys don't do this answer check, it's going to be really hard for you. Number 3, here we go. This is when you guys actually get to see me and how fat I'm getting. Here's my log expression. I have an idea of what's going to happen on this log, and hopefully you guys start to pick that up as well. Just make sure you're thinking those questions through. So first step, if there's multiple logs on one side, I have to condense them. There are no logs over here. That might tell us something later, but for now, it just tells us we don't have to worry about the right side. There are 2 logs on this side, and they're separated by addition. You have to know your properties in order to do this. Notice that none of my bases on these log equal log equations made any difference, but they might make a difference here. So I have to put these together by timesing my arguments together, and that means that these will go into a single log that says log base 5 of x times x, x squared, and x times positive 4, 4x, is all equal to 1. There are no other logs for me to condense, so I'm on to step 2, which is, which case do I have? Is this a log equals a log, or a log equals a number? This is a log equals a number. So what do I do with it? I'm going to change it from log form and put it back into exponential form, okay? Well, what's exponential from? It says, what's your base? Your base is 5. What's your power? Your power is over here, so it's 5 to the first. And what is it all supposed to equal? X squared plus 4x. Okay? Now all I have to do is solve. Whatever this power is, I have to do it. 5 to the first, that's easy enough. That's just going to give me a 5 is equal to x squared plus 4x. Looking at this x squared and this x, I'm probably going to have to do some sort of quadratic solving, which means I need this to equal 0. So I'm going to move the 5 using subtraction. Now everything's equal to 0. Now I can actually solve this. I have to think of 2 numbers that'll times to negative 5 and add or subtract to a positive 4. I only know one way to make 5, and that's 5 times 1. I need them to times to be a negative, but they have to add or subtract to positive 4. So my 1 is my negative number. So my possible answers, these are my factors. My possible answers are their opposites, negative 5 and positive 1. We're not done though. We have to plug these back into our arguments and make sure that we get positive arguments. So starting with number 5, negative 5 in fact. If I plug negative 5 in with positive 4, negative 5 plus 4 is negative 1. I can't have negative numbers in my argument. I don't even have to check the other log to know that negative 5 isn't a number I can get. Okay? 1. Let's check 1. Plug it back into this x. 1 plus 4 is 5. That's okay. Plugging it into here, because it's another spot that I have an x, is positive 1. I can use positive 1 because it's positive. So the only actual answer I'm allowed to use here is positive 1. Okay? All right. On to number 4. This one's probably going to be a little tough for some of you. It'll be real fun if I get lost in this problem. Okay. So I see multiple logs on one side and just a number on the other. You probably already are thinking it's going to be a log equals number question. You're correct. I have to put these together. I have to condense them using multiplication, but this multiplication is going to be tough. You guys are going to see me come up with an answer here. You have to times x minus 8 and x minus 12 using the FOIL method or the box method to come up with your answer. I can do some of this in my head. Hopefully some of you guys are to that point as well, but you're going to have like terms to combine. X times x will give you x squared. X times negative 12 and negative 8 times x will give you negative 8x and negative 12x. Putting those together will give you a middle term of negative 20x. And then negative 8 times negative 12, that is equal to a positive. 8 times 12 is 96. Oh boy, it's going to be a big one. All is supposed to equal 5. Okay? But here's the thing. I combined my log on this side. It's sucky, but I did it. And I see that this is a log equals a number type of question. So all I have to do now is rewrite this into exponential form. Well, what's my base? My base is 2. My log will always equal the power that goes on my base. My log is equal to 5, so it's a power of 5 that goes on to this 2. My argument is always the answer. Which was this whole thing right here. Not very fun, but it'll work for us. Okay? Now all we have to do is solve. Well, I do have a power that's not super easy, like this one was 5 to the first. If I don't, I can do 5 to the first really easily. 2 to the fifth, that one takes me a little bit of time. I have to actually do 2 to the fifth in my head or on my calculator. 2 to the fifth is equal to 32. And I can see that if I want to solve this thing, I gave you guys all quadratic examples here because those are the hard ones. All of these have been quadratic, so let's see, what do? We need them equal to 0, and then we solve them from there. So I need my squared term to stay positive, so I'm not going to move any of this stuff, but I will subtract the 32 that's on that side over here with the 36. Now everything's equal to 0, and I have to think of two numbers. Well, hold on, give me a second here. Let's see, that's going to give me 4 and 6. Oh boy. All right. So now I have to actually try and factor this thing. I have to figure out two numbers that will times to give me positive 64, but when I add or subtract those two numbers, I'll get 20. So let's think. What's going to get me to do that? Taking me some time. 64. Let's see. 64. I'm trying to pretend like I'm being you guys. Start trying some numbers. 8 and 8, those won't go together, make a 20. I was thinking perhaps 12 and something, that's not going to work. 2 and 32 isn't going to work because those don't add or subtract up to a 20. What is going to work? 16 and 4. Both 16 and 4 will times to 64, and when I add or subtract them, give me a 20. But here's the thing, I need them to times to positive 64 and add or subtract to negative 20. So I need them both to be negative so that this whole thing works out. So what are my potential answers? My potential answers are the opposites of my factors. So instead of negative 16, one of my answers could be positive 16. And instead of negative 4, one of my other answers could be positive 4. Now this is what I get if I solve this quadratic, but I have to think about, do these work for logs? If I plug either of these back in to these arguments, will I get an argument that's 0 or negative? If I do, I can't use it. So let's check. 16. 16 minus 8, that's 8. That's a positive 8. That's okay. 16 minus 12 gives us 4. That's positive 4. So 16 will work. There's no other logs with x's in them, so I know 16 will work. Okay? 4. Let's see. Will 4 work? If I take 4, plug it back in here. 4 minus 8. 4 minus 8 is negative 4. I can't have negative numbers as my arguments, so 4 is not an answer we're allowed to use. All right. So you guys are going to notice this a lot of times. You're only going to get one answer out of the 2 that you get if you had to do quadratic solving to get there. Some of them will be linear solving. I just gave you guys the hard ones here. I'm hoping that you're okay doing linear equation solving. That's like no x squared stuff, just moving stuff around. But you have got to remember to check your actual numbers. If you don't check your actual numbers when you're done, you're going to have extra answers that may or may not work. And I will throw multiple choice questions at you that have both of them in there. And if you don't know which one doesn't work, you're going to be screwed up. So those are log equations. Hopefully you guys have a good time with those. Remember your properties, specifically the addition, subtraction of logs. Otherwise, I will see those of you that have questions on Thursday at 11 a.m. If any of you need to meet with me at a different time in Zoom because you're stuck on something or you have a question that I might be able to answer in emails, I do check them between essentially 9 o'clock and noon, and then again from like 2 to 3, just to make sure that I'm double checking those. In between that time, I'm trying to get some grading done. So I've done it for a couple of you already. If you have to have your own separate Zoom meeting, please feel free to ask, and I'm happy to do that. In the meantime, make sure that you do your quizzes on this, and I will see you all next time.